Hey there, space weather enthusiasts. Welcome to the Daily Space Weather Show. I'm your host, Dan, aka Smash-A-Mash. We've got exciting stuff going on. Some new sunspots, one formed in the south, one rose in the northeast. We've got a trans-equatorial coronal hole, a coronal hole high-speed stream on the way, and plenty more, including a cosmic ray report to bring to you today from the Smash News Network least busted name. In news, what we're looking at here is a 24-hour video from SDO featuring ionized iron in 211 and 171 angstroms. It is pretty sweet. And let's switch to 304 angstroms ionized helium to show you some features. The most likely place for a large solar flare might be this northwestern limb, as we do have a major sunspot group setting up there. However, the most activity has actually been in the northeastern limb. So here's a closer view of that setting sunspot group. And let's take a brief moment to look at the northern polar region. So now down there in the lower left, you're going to see some activity happening. Don't worry, we've got close-ups of that, but I just wanted to briefly show this crown prominence. Above the Earth scale there, you might see that. It's a filament hanging off the limb, the northern polar limb. And there are certainly plenty of filaments on the Earth-facing portion of the solar disk. And we have seen two major coronal mass ejections, which we will show you. First, the southern hemisphere, and again, a new sunspot did form down there as well. We'll get to that momentarily. There's also a huge crown prominence happening right now as we create the video at the southern polar region. We'll show you that later in the video. Like I said, the major activity has been going on up there in the northeastern limb. So not only did a new large sunspot rise above that activity, a significant coronal mass ejection was emitted from that region. Also, the most flaring. Some M-class events occurred from over there. There's a great view of that. Fantastic imagery there from the Solar Dynamics Observatory. And before we look at sunspots, a little more close-up. If you were not aware, we have a home page. So help out the channel with clicks. Smashomash.com is the homepage, and welcome to the Neo-Renaissance. If you enjoy the videos and would like them to continue to be existent, publicly visible, and free for all to view, support the channel. Don't just press the like button, but do press the like button, and also visit our links. You can find links below the video in the description. Some of the links you can find are the link to our Redbubble shop. Today's featured product is one of the channel taglines, "May that solar wind be at your back," along with an ultra-high resolution image of the closest star in that wavelength we were just showing, 304 angstroms from SDO. You can get this one printed on the back of your shirt if you like. That's today's featured product. The one I'm wearing contains words that shall not be uttered. Words that shall not be uttered due to the pathetic state of censorship on the internet. Another great place to shop would be our Amazon shop, amazon.com/shop/Smash-A-Mash. Today's featured product is the B-complex vitamins. If you want to know what supplements I take, I became a pro cyclist back in 1999 on the cross-country mountain bike. And you can find many of those, in fact, most of the supplements that I take, you can find right there on that Amazon shop. So check those out if you like. Full disclosure on my supplement intake. B-complex is super important. I won't get into it any more in-depth than that and start talking about thiamine and niacin and so on. You can also find a link to the Hemp Lucid shop, another one of our paid affiliate/sponsors. Thanks to everybody who has picked up products from Hemp Lucid. Let us know in the comments if you have and how they've been working out. So various different products there, from the CBD tinctures to the mushroom gummies and mushroom stacks, stress stacks. Also body balms, CBD soft gels. Don't forget the lip balms. They make great gifts. Also CBD for your pets. And the Delta 8 product line. Also the THC-free product line available there at hemplucid.com. Again, you'll find links below this video in the description, as well as a link on our homepage at smashomash.com. So do your shopping via our shops. Help support the channel that way with some tangible items, and let us know how they're working out for you. We are always interested in that. If you want to just support the channel financially speaking, consider becoming a member of the Smash Team. We are still on Patreon also. Smashomash.com/Smash Team is our custom subscription services site. Give Smash staff a raise by becoming a gold or a silver level Smash Team member. If you want additional content, join the Smash Team. We also send out email alerts. There's a bronze level that costs you $0 per month. Smashomash.com/Smash Team, and let's get back to space, a frontier. Smashomash.com/Smash Team. Oh, and by the way, there's that crown prominence I was just talking about. We'll show high-res imagery of that in a bit. So here is the past. That is yesterday plus today. That's September 10th through September 11th to date. And there is one rapidly growing sunspot here in the southern hemisphere, right there by my pointer. Also, a large sunspot just rose up here in the northeast. And I would note the huge latitude difference. So we're not just seeing sunspots around the equator, we're seeing sunspots at very high latitudes. So that is what you can expect to see for the next about 2 years, as we're still about a year away from solar maximum. Here's SDO magnetogram for that same period of time. That is yesterday, September 10th, and today, September 11th to date. Next, we're going to talk volcanoes and check out these images. Some lava fountains occurring there at Kilauea's Halema Uma'u lava lake, which has inflated and then deflated again. There's another photo of Halema Uma'u lava lake. Go ahead, you can say it aloud, folks. Halema Uma'u. It is not a fictional Star Wars thing. It's part of the Kilauea complex. Anyway, as far as what else is erupting, Sakurajima is producing an 8,000-foot plume of volcanic ash. Mayan, a 9,000-foot plume of volcanic ash. Krakatau has been exploding. Dense gray to black ash plumes rose about 1,000 meters, so about a 3,500-foot ash plume there over Krakatau. Semeru produced a pyroclastic flow. Don't be in the way of one of those. Don't become part of the lithosphere. It could be unhealthful. Also, Vulcanian-style eruptions there at Semeru, located on East Java, Indonesia. Dakono producing an 8,000-foot ash plume. And there's a long write-up here on Kilauea. Basically, what's happened is the lava lake level rose, but less than a meter, and now it's dropping again. So it looks like sulfur dioxide levels are about to max out, and then those are expected to drop also. So just sort of a minor eruption there at Kilauea. Popocatépetl exploding in central Mexico, producing a 21,000-foot ash plume, flight level 210, flight level 140 over Santiaguito in Guatemala. Volcanic ash not detected on Fuego. Don't assume it's not erupting. Sangay in Ecuador exploding, flight level 200. It's a 20,000-foot ash plume, 24,000-foot ash plume over Sabancaya as it explodes in Peru. It's a 24,000-foot ash plume, and let's get to seismic activity. Here at the Smash News Network, least busted name in news. There's the past 90 days depicted in a convenient bar graph for you. We will call out quakes of a 5 or greater magnitude. Starting with this 5.3 at Japan. That was at 15:01 Universal Time yesterday afternoon. 5.3 strikes Japan. And then only 2 minutes later, much farther south at the Kermadec Islands region, there in between New Zealand and Tonga, we have another 5.3. So almost simultaneous quakes there around the West Pacific. After that, no 5+ magnitude quakes for an extended period here, although some significant earthquake activity around Hawaii. Lots of quakes there, just not of a 5 or greater magnitude. Finally, South Sandwich Islands saw a 5.1 at 5:14 Universal Time this morning. And the central mid-Atlantic ridge there seeing a rather large quake of 5.9. Right in the middle of the Atlantic Ocean there, right practically on the equator. That 5.9 was at 9:20 Universal Time this morning, and it's time to get back to space. So here's the past 24 hours in SDO 171 angstroms. That's the house favorite wavelength. Let us know what your favorite wavelength is from the SDO AIA instrument. Is it 335, 94, 131, 211, 193? We want to know. And let's talk space weather stats. The 10.7 centimeter radio flux now modestly rose to 164 solar flux units. If you're wondering what that is excited hydrogen down in this transition region, the lower corona and upper chromosphere. Right around that area right there. That is the radio emissions from the hydrogen. And it is a proportional data set to sunspot number. Here's a 1-year chart. To contextualize that, the black line here is the radio flux. The red line is a sunspot number. And these are both going to rise. Sunspot number is going to go up at least another 18 today. So it's currently at, the red line here is showing, 167. It's going to go at least to 180 plus. And I wouldn't be surprised to see the radio flux travel up with that. So those are proportional data sets. In other words, when you see a higher radio flux, you see a higher sunspot number, and vice versa. Also, we've got some coronal hole high-speed streams on the way, which we'll talk about here in a minute. There's the forecast from NOAA. That's the Space Weather Enthusiast dashboard. Expecting some geomagnetic unrest late in the day tomorrow on September 12th. I think the density wave is going to show up sometime around midday tomorrow on September 12th. So expect a high density spike happening tomorrow around midday. We've got more coronal hole high-speed stream activity also. We'll tell you all about it here in a moment. First, let's take a look at Earth's magnetic moment from space. So that's the last 4 hours of magnetohydrodynamic pressure, nanopascals, Earth's magnetic moment from space to about 12 Earth diameters. Pretty chill at the moment. Earth's magnetic moment from the ground also pretty chill. It is geomagnetically calm conditions for an extended period of time, actually. Looks like Greenland got some significant northern lights. And if you got imagery of the northern lights, why not share it with us on social media? You can hit us up at various different spots, whether it's Instagram, Twitter, or better yet, our Discord chat, which is conveniently linked on the homepage. There's a permanent invite link to that at smashomash.com. Planetary K-index at 1.67. Again, quite geomagnetically calm conditions. And let's take a look at the solar wind. Solar wind here, just under 7 protons per cubic centimeter. That's the density, solar wind speed. Very nominal there, around 400 kilometers per second. That's sort of quite an average solar wind speed. Again, expect an uptick around midday tomorrow in the solar wind density. That's the initial density shock wave of the coronal hole high-speed stream that's likely to show up tomorrow later in the day. Then when that density drops off, the speed will rise up. GOES magnetometers here are quite smooth. And it looks like the GOES 16 is maneuvering as we create the video. So those arc jet moments, that is plasma created by the thrusters on the GOES 16. They can affect the magnetometer. That's why they show it on the graph. And continuing right along, here is the top view ecliptic plane field plot. One of the most important data sets that we show daily on the channel. It shows sector boundary crossings and the polarity of the heliospheric current sheet. So Earth still is kind of right in the middle of a South Pole current sheet. North Pole current sheet there a few days out. If you look at the last image, there is a sector boundary crossing. There is a North Pole current sheet. Earth is in a South Pole current sheet. Next, our line of sight field plot, where the solar B field is depicted in blue. That's the field that goes through the magnet, if that magnet's the sun. Polar fields in green for north and red for south. And of course the gong magnetogram in grayscale. And let's go to the coronal hole line of sight plot. So we do have a trans-equatorial south pole oriented coronal hole here, rotating right through the Earth strike zone. That'll be about another 3 or 4 days until we see the changes to the solar wind from that. So we'll see another density spike, and then a density drop, and then a velocity spike in the solar wind data from that coronal hole high-speed stream. The trans-equatorial type are the most geo-effective. So that's a perfect example of a trans-equatorial coronal hole system. And let's move to the SDO once again to show 211 angstroms. That is our South Pole-oriented coronal hole system. Next, we've got sunspots, and like I said, we've got new ones. And we've got a lot of sunspots on the Earth-facing portion of the solar disk, which are the only ones that we count, by the way. So the flare monitor here is suggesting a very high likelihood of X-class flares and M-class flares with this group right here, 3423. There is also a high likelihood of large flares over here at the northwestern limb and also around the northeastern limb. We certainly see a lot of plasma motion going on up there. So the northern hemisphere is probably the most likely spot to see a large flare. Quite a lot of different areas there where we could see a large flare. And next we'll show some imagery right before we do our cosmic ray report. So there is the past 24 hours in SDO continuum. I almost forgot to mention there is one new sunspot that's rather rapidly grown down here. Right there, you see the full growth of that sunspot. Also a little bit of growth in that group north of the Earth scale there. That is a lot of sunspots. And if you're worried about a grand solar minimum, and that imagery right there doesn't convince you that it's not a grand solar minimum, you may have joined a cult if you've become so ossified in your beliefs that you are unable to listen to reality, and you are instead convinced of nonsense. You may have joined a cult. Cults have one feature, folks. Well, folks, cults have 3 major features. They have a living leader, they're harmful, and their members believe nonsense. So that's one to grow on. And here's one to grow on. Cosmic ray report. So cosmic rays are very similar to the solar wind. They are mainly hydrogen nuclei. They come from places besides the sun. They come from outside the solar system and perhaps even outside the galaxy. It's very hard to know exactly where they come from. We only know of one for sure cosmic ray point source, the star Deneb, the brightest intrinsic object visible from our solar system. And again, cosmic rays are very much like the solar wind. They're mainly made up of hydrogen nuclei. So you have just a proton and a neutron flying through space at very high speeds. No electron is able to hold on to them. And so when they show up at Earth, they cause particle showers. They cause additional ionization. They cause more chemical reactions. Sometimes they even cause nuclear isotopes to be created if they blast a neutron off of something. So they're quite energetic particles. They're smashing into Earth all the time. Mashing into Earth all the time. Cosmic rays. So we've got about 7 different monitors that we're going to show here. Here is a Patati neutron monitor, which is showing, interestingly enough, an uptick over the past 30 days. So we've got a long way to go to solar maximum, folks. And that is just another lull in the activity there. An uptick in cosmic rays at a Patati over the past 30 days. Barentsburg, flat over the past 30 days. And you can expect both of those to dip in the next year. Next, we'll go much farther south to Athens, Greece, which is also showing a slight uptick over the past 30 days. How you like them apples? So that's Athens. We'll go even farther south to Mexico City. There's Mexico City. Quite flat over the past 30 days, maybe a slight uptick there. So almost completely flat at Mexico City. And then we'll go way up north. Why do I keep switching? We'll go way up north to the Oulu, Finland neutron monitor. Oulu, Finland exhibiting an uptick over the past 30 days of cosmic ray flux. And then we'll go as far south as we can get to Antarctica. There's DOMB, an uptick over the past 30 days. And there's DOMC, an uptick over the past 30 days. So overall speaking, folks, we have an uptick in cosmic ray flux over the past 30 days, something you would not expect unless you were not yet at solar maximum. So if these facts offend you, we're terribly sorry, because here at the Smash News Network, Least Busted Name in News, we are obsessed with facts. Next, the ghost proton flux. We don't have any spikes in it. These relativistic particles are typically associated with large solar flares, and despite having 2 M-class events over the past 24 hours, no spikes in the proton flux. So there is the largest event over the past 24 hours. It's an M1.37. Peak flux was around 1:30 this morning. And let's take a look at flares. Where do you think they came from? Let us know in the comments. Make sure you leave a comment quickly, because it's going to be too late. Here's the past 24 hours in SDO 94 angstroms. So it looks like those M-class events both came from the eastern limb there, on both sides of the equator. So that's 94 angstroms. Again, we've got multiple places where we could see large flares. We certainly have the type of magnetic field complexity required for that. Here's 131 angstroms, and it is exciting times to be covering space weather. Is it the calm before the space weather storm? I would say so. Sometimes when you're so ahead of the curve, folks, people think you're incorrect with your forecasts until you become correct, and then they'll just try to gaslight you. It's pretty hilarious. But anyway, yeah, very likely to see large flares, especially in the northern hemisphere, as there are several large and magnetically complex sunspot groups, what we call beta, gamma, delta class sunspots. So next we're going to take a brief moment to stop staring at the sun from so close. Here's a star chart for what's going on over Lehigh Valley, Pennsylvania. If you want to make your own, head to skyandtelescope.org. I really like this one. I like the way it's easy to just move it around and see what your view would look like. Very nice. Of course, there's the largest object visible. The largest object visible with the naked eye, the largest single object at least, Betelgeuse, a red supergiant star that is so big it would be like the size of Mars's orbit if it was located in our solar system centered where the sun is. If you are up before dawn, you might see the third brightest object in the sky, Venus. And if you've got low horizon, clear skies, and low light pollution, you might be able to see Mercury there, heralding the rise of the closest star. Speaking of which, there's the third brightest object, Venus, along with Comet Nishimura, which is going to be at its closest approach for the next 434 days? It will pass its nearest to the Earth for the next 434 years. Oh, not 434 days. Yeah, so Comet Nishimura there. The astronomy photo of the day. The sunrise sky featuring Venus. And the comet, which I believe is closest to the sun, on September 17th. Next, we're going to show a solar system forecast. Whether or not that's space weather is up to you. Here's your 1 week forecast for the solar system. As we approach the new moon of September, that's where things will be on September 18th. And let's talk CMEs. So we did have a spectacular one happening late in the day yesterday out of the northwest. So there you can see that on these 104 frames from yesterday from the George Mason University. Fantastic CME there popping off. We'll let you know if we think it has an Earth-directed component here after further analysis. I do the analysis as I record these videos, as I have nothing to hide. The truth is out there, and that is what we're interested in on the channel. So here are an additional 43 frames from yesterday, another CME popping off on the eastern limb there. We'll let you know if that is likely to have Earth-directed components. First, we'll show the C3 also. Nice. And here we've paused at about 2000 universal time for the C2 and 2300 for the C3. We're going to let those advance. So there's that northwestern CME. And then, of course, that eastern CME. And let's take a look at our custom coronagraphs. Actually, before we do that, we'll show stereo A, which unfortunately is not super helpful. So here's the eastern one at least. There's the difference imagery. And here is the raw coronagraph. Doesn't look like it's earthly directed, but you never know, so let's switch to our custom views. Dag, this is a good one. Here's a 24-hour video with SDO 193 angstroms, as well as those LASCO C2 and C3 coronagraphs located at Lagrangian point 1. So the SOHO spacecraft there in blue and red, and the SDO synced up in that central bronze-colored imagery. The verdict? I don't think any of those are earthly directed. The first one will miss to the northwest. The second one will miss to the east. If either of them were likely to have an earthly directed component, it would be this one, but I don't think it does. Let's zoom in one more step here. You'll see some plasma motions up in this area. But all of the limb darkening happens up in the northeast, so not likely to have any portion directed toward Earth. And here's a little closer view of that before we get to filaments. So filaments are a serious, wow, we've got some, check out this filament down here. This is called the Eugene Bagashov filament. We've been naming filaments after living people. And there are some gigantic ones. So let's have a look, shall we? Just kidding, folks. I'm not really asking. This is a dictatorship. You're living in a plutocratic corporatocracy. And this channel is a dictatorship. I'm showing you what I want to see. And what I want to see is, dag, look at the size of those filaments. Let's show the latest image here and then count. Geez. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'll say 10. I don't know. That looks like 2 there. So at least 10 filaments on the Earth-facing portion of the solar disk. Major filaments. And by the way, if you want to name them after living people, just join us over on X. Just kidding, folks. It's called Twitter. X is not a brand. X is a letter. And I just refuse to call the platform by a letter. I prefer actual brands. And so, again, if you want to name filaments after living people, just join us over there and just follow the hashtag #NameThatFilament. America's favorite pastime. Name that filament. Just don't name this one down here in the Southwest because that one's already named after Eugene the Philosopher. And by the way, make sure you follow him on YouTube. Eugene the Philosopher. Let's get him to 1,000 subscribers so he can monetize his channel and blow up, as YouTube is going to totally recommend him. Because ads? Anyway, here's the grayscale imagery. That's also El Teide, Spain, hydrogen alpha. The grayscale does show prominences, and you can see quite a few of them. And let me just tell you, there is one happening right down here in the southern hemisphere. Let's cut to that. Yowzers! So that is pretty sweet indeed. Check it out. Huge crown prominence happening as we create the video. Let us know in the comments what you think that one's going to do. Is that going to reorient? Will it just anchor itself to another spot? Will it splash back down toward the chromosphere? Or will it become another coronal mass ejection? I know what I think. What do you think? Leave a comment and tell us all about it. There's the full disk view. That's the past about 2.5 hours from the GOES 16 SUVI. Ionized helium. And it's time for bonus features. First bonus feature is satellite charging hazards. We don't have any of the surface or internal charging variety. Those low energy and high energy electrons are not building up on spacecraft at the moment. Smooth sailing for satellites. The GOES electron flux here is kind of low. It looks like it is a little bit lower than it was yesterday, but fairly consistent. That is a 3-day chart using the radiographic measurements by the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. Here is the 1-year chart to put it in context. Again, kind of low levels there. That graph is from Solon.info, and NOAA's forecast is for another dip in electron flux. I would tend to agree, as there is a coronal hole high-speed stream likely to strike starting midday tomorrow. Next, we'll show the layer of the atmosphere where that's measured, the F layer of the ionosphere. Feel free to pause the video if you're not familiar with the data depicted. Here's the vibrational frequency of the bridge between Earth and space. The F layer is located 300 kilometers of altitude. That is showing the vibrational frequency of the material in that layer. It's mostly ionized material, hence the term ionosphere. Vibrational frequency depicted here in megahertz, millions of vibrations per second. Interestingly enough, my IBM PS2 Model 25 was about this fast, about 10 megahertz. We are seeing quite a bit of high frequency anomalies happening here. This is common when you don't see any geomagnetic activity. And here you'll see a lot of blue. On the anomalygram, it depicts anomaly in megahertz from a 30-day median. So mostly high-frequency anomalies happening there, and some significant ones, especially south of the equator. Again, it shows low-frequency anomaly in red and high-frequency anomaly in blue. Before we show the total electron content, let's show the latest image. There's 12:15 universal time for the ionogram and 12:15 universal time for the anomalygram. Total electron content is free electrons to about 12,500 miles of altitude. It'll show you the likely places for GPS errors, and there you go. There's the global coupled thermosphere, ionosphere, plasmasphere electrodynamics model. It is literally a count of free electrons between your GPS satellite and your GPS handset. And things are fairly orderly here. They might get a little more disorderly when that coronal hole high-speed stream shows up. That is a common feature. And we'll show the 10-day anomaly over North America. So this is still total electron content, but it's the anomaly from the 10-day average. We are still seeing some high electron content anomalies there over portions of Canada and Central America. We're closing out the space weather section of the video with the latest intensitygram and the latest colorized magnetogram. So yeah, that's just a lot of sunspots. I'm going to summarize. That's a lot of sunspots. We've got this new one in the northeast. We've got this new one in the south central region. We've got many magnetically complex sunspot groups that harbor the kind of magnetic fields that can produce large solar flares. And we'll just briefly show this one here. It is indeed a beta gamma delta class. Eventually the Earth-facing quiet will subside. And if that one does not degrade, it will become increasingly likely to produce an M or even an X-class event. And that brings us to meteorology, because it's time to show some of the hurdles that this Atlantic hurricane is facing. So it's not just facing dry massive air, it's also facing some anomalously cool water. This water here in the western Atlantic is about 3 degrees Fahrenheit cooler than normal. And it's on a collision course. It is on a collision course with that cooler water, folks. That will not help with convection either. Now keep in mind, the sea surface temperature is still pretty warm up there. So it is still nearly 80 degrees. However, it is not as warm as it is normally for this time of year. This depicts wind in the animation portion and sea surface temperature anomaly in the color gradation portion. So we're going to show the world's oceans here and sea surface temperature anomaly. There is the Atlantic. Here is the Arctic. Next, the Pacific. How about the Southern Ocean? And by way of completeness, there is the Indian Ocean's sea surface temperature and surface winds. Now we're going to switch to just surface winds here. Here are the wind patterns of planet Earth. There's the eastern world. Here are the jet streams. Here is the central world's jet stream scenario. Here is the central world's surface wind scenario. And here is the west. So that hurricane is still a major hurricane, but it does face some hurdles. It does first some Hades. There are the jet streams of the west. And check it out. Here come some forecasts. This is the Euro forecast for the next 3 days. So that is where things will be on Thursday. We're going to move this ahead to 12 noon Eastern time, which would be 1600 Universal time. As you can see, it's turning a bit to the north there. And there is cooler water there. There's also dry massive air ahead of it, which we'll show you here in a minute. There's where the GFS forecast puts it very much in line with the Euro forecast. So there's the GFS forecast for Thursday at 12 noon Eastern time, and there is the Euro forecast for 12 noon Eastern time on Thursday. Here's some satellite imagery for you. And let's take a closer look there. There's our shortwave radiation map. And it may look like it's a little bit weak on the leading edge of that. And the reason for that is because of dry massive air. So this air right here is a relative high pressure zone, and it's basically bumping into this, and it's going to be robbing it of energy. As you can see, it's not super organized. And that entrainment of dry massive air is good news for those on the East Coast that don't want to get struck by a hurricane. So clear skies overhead are not conducive to hurricane growth. I think I might have said something about it yesterday. And you too can forecast your weather if you understand atmospheric physics. Anyway, here's the weather.gov map. Weather.gov, if you've got weather warnings, head to weather.gov. Those are like fog advisories, I think. However, those are too many counties to cover. So if you've got weather warnings, just head to weather.gov and click your county. Here comes some forecasts. Here's the GFS forecast for the Atlantic. And as you can see there, indeed, that is expected to turn almost due north and weaken just a little bit in the coming days. I would suspect it will continue to weaken as you go farther north in the northern hemisphere. The water's going to get cooler and cooler. Also, the jet stream may start to have influence by about Friday. That will create additional wind shear and likely cause additional weakening of the system. Facts. If they make you mad, please unsubscribe from the channel. Next, 72-hour GFS pressure and precipitation forecast. And it is actually showing it breaking up a bit there. And here is the total accumulated precipitation forecast in inches, based on the same 72-hour GFS model. Some heavy rains are coming to Texas. Looking like some areas with like 4 inches of rain in the forecast. Yowzers. Last but not least, here's the jet stream forecast. And again, it looks like the jet stream is going to start to affect this thing, although it's kind of weak. So, a combination of wind shear and cooler water there is not going to be conducive for the growth of this thing. Hopefully it doesn't suddenly make a turn to the east, but at the moment it doesn't look like it's able to do that. Next we'll show lightning for the past about 10 hours. Here's our lightning mapper. And Texas was the lightning capital of the U.S., with a close second for Oklahoma per square mile. I think Oklahoma actually had more lightning per square mile. More per capita lightning in Oklahoma than Texas. And here's a real-time lightning map, courtesy of lightningmaps.org. If you want to convince the natives that you're Thor or Zeus or something like that, try lightningmaps.org. You might be able to forecast thunderclaps at Tampico. Seriously, next time you hear thunder, lightningmaps.org. It could actually save your bacon, or perhaps your beef, or what about your chicken? I don't know. If you enjoy the content, make sure you press the like button. Leave us a comment. Press share. It took us quite a while to figure out how to cover the daily space weather, and we've been doing it for over 6 years now, thanks to our new subscribers over on YouTube. Tell your friends and foes, and we're showing the shorts here because of the roiling success of the shorts. They're great for people with attention spans less than 1 minute. Yeah. So we conveniently put those shorts together, and people seem to like them. So anyway, thanks again to our new subscribers. Help us reach 5,000 if you're new to the channel. And press that subscribe button. If you're old to the channel, press the like button, etc. Tell your friends and foes about us. Pick up some merch. Visit our links. Thanks to everybody who has. We'll close out with U.S. Doppler radar. Some heavy precipitation there around southern Alaska. We'll be focusing on the lower 48. Some heavy rain moving across Michigan. Here is clouds and fog. I should say here are clouds and fog. And here is the water vapor map. If you're looking at your Doppler and it's looking unclear as to what's going to happen next, it works in the wintertime and the summertime. Use the water vapor map. If you understand things like that this air here is more massive than this air here, hence it being high pressure versus low pressure, you'll be able to forecast your weather. Anyway, here's a recap. Vertical motion in the air column depicted by ground-based Doppler radar systems. Some heavy precipitation here moving across Illinois, Michigan, Kansas, Oklahoma, and Texas. Here is the shortwave radiation map depicting clouds and fog, even when it's too dark over half the country to use a visible satellite. And there is water vapor. It shows the dry air, it shows the moist air, and it will enable you to forecast your weather. Thanks to everybody who's tuned in. Once again, congratulations on realizing the channel exists. We're frankly surprised that you found the channel with the state of affairs on social media. Anyway, I'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.